to solve this error problem. It's actually an RK2 global error bound problem. I think that's what it's called. It's actually on your slide, so they actually try to solve it, but they're not so explicit in terms of where things come from and where they go. So I'll try to actually see if I can maybe try to explain it better if possible. But yeah, let's just try. So we're trying to go to x is equals to 0.3 from x is equals to 0. That thing will have how many steps? 3 steps. Right, where x1 is equals to 0.1, x2 is equals to 0.2, x3 is equals to 0.3. These are our steps, right? And then I did talk about this earlier, that global error at wherever I am is going to equals to the error from the previous one. Actually, it's better if I say global error in the next one is going to equals to the error at the previous one, making this plus global error at the previous one, but multiplied by some factor here. So that factor in this case, let's just call it alpha, like that. Yeah. Let me think about what I just wrote. Oh, actually, I'm wrong here. The error where I'm at should equals to the local error where I'm at multiplied by here's the previous stuff. Because what I said in class, actually, I said that global error is error that you have after taking some step, and local error or triangulating error is error that you have for taking that step alone. So it's like that step costed me this much error. That's what we call local error. So this guy is a local error at that step. This one is global at that step. So it's a sum of all the previous errors, but now they have some sort of factor or scaling factor, right? So this one we can assert, can we? On top of that, let's just say something that I did say in class is that error at 1 or global error at 1 is equals to whatever error that I accumulated at that step 1, because there are no previous steps, and global error at 2 is going to equals to error at 2 plus global error that is previous multiplied by a factor that I get. Let me call it factor 1. Then I can simplify this thing better and call it E2. I shouldn't be calling it E2, but I just like doing that. Plus, then sigma 1 E1. I'm just substituting this guy just there. Then error 3 or global error, that step is going to equal to whatever the error that we make at 3 plus the previous global error, and now it is factored by alpha 2, which is going to equal to E3 plus alpha 2 E2 plus, okay, I think I'll need some more real estate. I'm hoping this problem could be shorter, but I don't look like I'll be able to make it that short as I want it to be. Alpha 2, alpha 1, sigma 1. So if you think about it, the third the third global error is literally a sum of all the errors that I've accumulated, error 3, error 2 up to error 1. But now all these errors, they're not just errors, they have some sort of factors. These are factors. They are factored, or maybe they are weighted. They are weighted some, depending how you want to think about it. So then error at 3 or global error at 3 is going to equals to E1 absolute plus alpha 2 E2 plus alpha 2 alpha 1 all absolute and then that, right? So it's going to, this is either going to be big or equals to area there. We just showed you where I took that statement from. Okay, let's try thinking. Remember, we're trying to find the error bound, right? So to find the max, we're going to look at the worst case scenario. So since I said we're looking at the worst case scenario, we want the magnifying factor or the scaling factor to be less than magnifying factor at some position to be less than something called alpha, of which is a maximum actually scaling factor, right? That means in these things, instead of having this alpha 1 2, we could just have alpha alpha alone, because alpha is a max. Actually, alpha is actually a max of alpha 1, alpha 2 and alpha 3. So if we want to find the worst case scenario, we're going to use alpha for each and every one of these things. So from that equation, you just go copy it. So this is now our equation. So we already agreed that we're going to remove all the alphas with just alpha, because alpha is a maximum. So we're looking at the worst case scenario, because there were two of them. Now I'm going to make it. Okay, let me make it like that, because I'm trying to find a bound. Also, for it to be worse, also we want to find something called E. Convention we call it E. We want to find the max of all E1, E2, E3, and call it E. Then use it in terms of using just E1 and E2. So if that's the case, if we can make all these things equals to one max, of which is what I get from there, I can just factor that thing out, of which will be just a max. It will be a max of E of the errors, local errors. That means I just factored it out there. Then I'll have inside here I'll have just 1 here plus that plus that, right? So now this thing look familiar, at least I remember something. I think we talked about this in calculus 2a, called geometric series, of which it can be written as it's actually a very good definition, that 1 plus alpha squared blah 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 is the same as an minus 1 all over alpha minus 1. So in our case, this thing ends at what? So here it will be number of steps. So already agree that number of steps, make it big, N is equals to 3. So we know this thing now will have a 3 here, and we're going to plug it just back where it belongs. So I can remove this geometric stuff. You can just go to revisit your calculus and see if whatever I'm saying here, I'm saying the right thing. Since I don't want to dwell there, because there's a cause that actually emphasizes and explains those series. So now I can have alpha 3 power minus 1 over alpha minus 1. So now we have an equation to kind of look better. If we know what is this alpha, we would have been able to compute here. So I think we will have to go somewhere else and try to see what we can make out of it, because this thing actually is our final answer, but it's lacking parameters or input. We do know that alpha is equals to, or an amplifying factor is equals to 1 plus h and max of fy, or as x varies from 0 to 0.3, right? This one is a partial of f with respect to y. So I can go back to my equation and try if I can see partial of f with respect to y. So if I differentiate in terms of y, this becomes a constant, that becomes a 1, that becomes an x. So that's a good thing to have. We can go back to where we are. So now we know this, and if we're trying to find a max of this function, that's what we are trying to do, max of this function in this domain, it's easy because all these terms are being subtracted by 1. So actually max of df d respect to y have to be 1 because they are all being subtracted from 1. This means they are all getting less as time goes on. So now we can find alpha is equals to 1 plus h, we did say 0.1, and this max now we just said it is 1, so alpha is equals to 1.1. That will make, remember we had alpha 3 minus 1 all over alpha minus 1. We can now compute it because you know this one will be 1.1 squared minus 1 all over 1.1 minus 1, which is going to give us 3.31. So on this problem, on this we said this is our answer. We already know this small part here of which we just said it was 3.331. Obviously I think you need to be careful with this, means now we have to find this guy, then we can now be good to go. So now let's focus on this term that we don't know anything about. So that will be us finding a max of error local in the bounds of 0 to 0.3. And I think if it wasn't given, we know that it's h3 all over 6 max from that domain. Let me just see, domain y1, 2, 3. I think this was given, if I'm not mistaken, all over 6. So now it will be us finding this guy because we already know this guy is 0.1. We have to find the max. That will be our next measure. But now differentiating a function that is in terms of x and y, we have to use some partial derivative chain rule tricks, of which I think we also covered them in calculus 2b. I think it's 2b, okay. But if I differentiate that y prime again, it will be f x, which is a partial derivative, and f y prime. If I do it again, I'm going to get y1, 2, 3, of which is going to be, also this is mainly relying on calculus f x plus 2f x y prime plus f y prime. Now it's going to be squared plus f y double prime. So these identities, obviously you can make them up from using maybe your multivariable chain rule. They are followable if you're really interested. So because I'm trying to make the video short, after plugging in everything that you can plug here, of which you obviously can, you'll find that y up to the third prime is going to equals to, also pause the video to make it short. So you'll get this if you do everything right. So yeah, also I think I did mention in class that you can actually find the max of a weird function. So the code is trying to find the max of this guy in some domain 0 to 0.3. That's the goal. I use that calculator trick that I showed you, or you could do it analytically, of which you could differentiate again and make it 0 and all that, or just plot it in a calculator and see what it actually gives you. That's what I normally do. I plot it and look at the different values and actually spot the max. So my max that I got, the max of, max in a domain, max of y123 is equals to 2.0159. So if you come here, you already find this, you already find this, and you're going to multiply these two numbers, and if my computations were correct, of which I hope so, I'll end up having my global error equals to 3.5 times 10 negative 4 multiplied by 3.3. The reason why this number is not the same as this, remember there's still h and whatsoever times here that will multiply and then make it that. So I'm just trying to make the video short and end in 15 minutes hopefully. And then I'm going to get 1.167 times 10 power negative 3. So that's my upper bound of a global error. That means error cannot be above this. We can't make more errors than this number. Remember, global error, if this is a step global error is a error that some of the errors you made here and you made here and you made here, but they all have some sort of factor to the next step. And also local error is an error that you only make if you are here. Is this error that you make by making that step, but global error is more of like an accumulative error if you want to think of it like that. So yeah, so this is the best I could do to explain the problem. Please go review it step by step. Try to, if you don't understand, go back to the part, but I try to explain explicit possible, except if there's just math that I feel like will make the video longer. But yeah, good luck on your exam again.